Good morning. This is the first lecture after our first exam, and it's on section 3.4, the product and quotient rule. So let's go ahead and dive right in. We learned in the previous lecture that the derivative of a sum of functions is the sum of the derivative. So ddx of f of x plus g of x is the same as ddx of f of x plus ddx of g of x. So now this question leads us to, well, what about the product of two functions? How do we get an answer for ddx of f of x times a function g of x? And this leads us to the product rule. And this is one of the very big rules, and it makes life really easy. You just have to straight up memorize it. So if f and g are differentiable at x, then d dx of a function f of x times a function g of x is equals to f prime of x times g of x plus f of x times g prime of x. And I remember this, the derivative of the first times the second function plus the first function times the derivative of the second function. So let's go ahead and look at an example. So let f of x equal x cubed and let g of x equal x to the fourth. From algebra, we know that x cubed times x fourth, you just add the powers together and you get x to the power of 7. So d dx of x to the power of 7 equals 7 times x to the power of 6. Now let's do the exact same thing using the product rule. So d dx of x cubed times x to the fourth. We take the derivative of the first, which is 3 times x squared, times the second function, x to the fourth, plus the first function, x cubed, times the derivative of the second, which is 4x cubed. We do our algebra and we get 3x to the 6th plus 4x to the 6th. Add those together, we get 7x to the 6th. So either way you work it, you're going to get the exact same answer and it's going to be correct. But this is just an example to show you the product rule works. You can always trust it. And when you have things that are more complicated than this, such as x cubed times e to the x or x cubed times ln x, you're going to be able to use the product rule reliably every time. So if we have a product rule, we better have a quotient rule. And unfortunately, the quotient rule is not nearly as simple as the product rule. In fact, it's very big and there's even a rhyme. So d dx of two functions, f of x divided by g of x is equal to g of x times f prime of x minus f of x times g prime of x all over g of x squared. So there's a rhyme I like to use to remember the quotient rule, and it's low d high minus high d low all over low squared. And this one, again, you're just going to have to memorize it. But let's look at an example to show you that it really works. In the spirit of the last example, f of x is going to equal x to the fifth, and g of x is going to equal x cubed. So from algebra, we get x to the fifth divided by x cubed. We just subtract the powers. 3 from 5, we get x squared. And d dx of x squared is equal to 2x. Now, using the quotient rule for the exact same function, we get low, so x cubed times the derivative of high, d high, that's 5x to the fourth, minus high, which is x to the fifth, times d low, which is 3x squared, all over low squared. So that's x to the sixth. We simplify using some algebra. We get 5x to the 7 minus 3x to the 7. That simplifies to 2x to the 7. X to the 6th stays the same in the denominator. And just like before, x to the 7 divided by x to the 6th is just x. We're left with 2x. So no matter what, you're going to get the correct answer. You're going to get the exact same answer if you're working just with x fifth, x cubed, x squared, things like that. So this brings us to the power rule. Now that we have the product and quotient rule, it might seem a little redundant, but the general form of the power rule follows. If n is any real number, it could be 1.2, it could be negative 5/3, it could be whatever, then d dx of x to the power n is equal to x, sorry, I put this in the wrong order. It should be n times x, where x is raised to the power n minus 1. I'll fix this before I post the slides. So finally, we can combine rules. So let's look at an example. Let's find the derivative of y equals 4x times e to the x divided by x squared plus 1. So go ahead and pause your video and see if you can't at least set this up before we get going. So I'm going to start right here. So find the derivative of y equals 4x times e to the x divided by x squared plus 1. So since we have a quotient involved, we can go ahead and set up using the quotient rule. So high d low low d high minus high d low all over low squared. And we see now in the numerator, we've got d dx of 4x e to the power of x, and that requires us to use the product rule. So here's the expansion of that using the product rule. And we plug that in right where we had the d high term in the very first expression. So now we get d dx of 4x e to the x divided by x squared plus 1 is x squared plus 1 times 4ex plus 4x e to the x minus 4x e to the x times 2x. All of it over x squared plus 1 quantity squared. So you might notice that we've got an e to the x or a 4e to the x in every term in the numerator. And when we go to simplify, we're going to go ahead and pull that out. So our final answer is 4e to the x. We've expanded our numerator term to be x cubed minus x squared plus x plus 1, all over x squared plus 1 quantity squared. And that's our answer. All right, that's this video. We're going to get a new video pretty soon.